Day 1 of Chapter 8 test review. We're starting with special right triangles. It feels like forever since these. Okay, how many special right triangles are there? There's 2. There's 2. What was one of them?
30, 60,
Yep, I heard both of them. 45, 45, 90. And then the other one is 30, 60, 90. So remember there were the diagrams that went with them. Okay, on 45, 45, 90, we're going to start there. I'm going to draw myself a right triangle. What do I know? I'm going to back up. How do I know a triangle is a right triangle? Has that right angle. Yep. And then the other 2 angles by its name are 45, 45. Okay. Talking about this diagram here, what do I know? What are some things that I know about the sides of a 45, 45, 90?
It's nice.
Okay, it's an isosceles triangle, which means that we have 2 angles that are the same. So what do I know about their corresponding sides? They are also the same. I'm going to represent those as x. Okay, those 2 sides are the same. Now we have to determine how to get to the hypotenuse. How do I go from the leg to the hypotenuse? Do you remember? It is multiplied by the square root of 2. Okay, I know back when we first started this, we were determining the difference between multiplying and dividing and how you know. Okay, if I'm going from a leg to the hypotenuse, am I getting bigger or smaller? I'm going from a leg to the hypotenuse. It's getting bigger, so I'm going to multiply. Okay. If I'm going back to the leg, am I getting smaller or bigger? Smaller, so I would divide. Okay. Am I ever going to use any other number than square root of 2 for 45, 45, 90? No, it's always going to be that square root of 2, whether you're multiplying or whether you're dividing. Capiche? All right, let's go over to 30, 60, 90. Draw yourself a right triangle. Make one of the sides obviously smaller than the other. Again, we have our right triangle. Which angle, top or bottom, is the 30? The top one. Yep, it's across from the smallest side. With 30, 60, 90 triangles, what leg or what side is the most important? The short leg is the most important. Yep, so I'm going to label that as X, and I'm going to circle that. That is the most important side. Okay? What I mean by that is if you know that, you can find the other sides. If you don't, then we have a problem. Okay? Out of the long leg and the hypotenuse, does it matter which one I find next? It doesn't. Nope. As long as you have the short leg, it doesn't matter. How do I go from short leg to the hypotenuse? Close. Multiple. This one's multiplied by 2. How do I go from short leg to long leg? That one's multiplied by the square root of 3. Yep. So I'm going to focus on going to the hypotenuse right now. If I go from short leg to the hypotenuse, we're getting bigger, right? So I'm going to multiply by 2. What if I go back to the short leg from there? We're going to divide by 2. Okay, what if I go from short leg to long leg? I'm going to multiply or divide? I'm going to multiply by square root of 3. If I go back, I'm going to divide by square root of 3. Can I go from long leg to hypotenuse or vice versa? No, no such thing. Okay? Have to find that short leg first. Okay? I will not be providing these diagrams for you. Okay? This is something you have to know. Okay, you remember the reasoning for those?
I thought you said the opposite.
ACT. Okay? When you have the ACT, they don't give you things like this.
Isn't that like next week?
Okay? So, I'm not going to provide them for you either. You have to memorize these diagrams. Now, when you get the test, can you immediately go draw the diagram? Yes. Okay, I'm just not providing them for you. So you just have to remember. So on this example, we have a 45, 45, 90. Okay, based off of the angles that they have labeled. It gave me a leg. Out of 1 and 2, does it matter which one I find first? It doesn't. Which one's the easiest? Number 1, right? Because legs are the same. So if this is 7, the other side is 7. Okay. How do I find the hypotenuse? How do I go from a leg to the hypotenuse? I'm going to multiply by the square root of 2. Yep, so I'm going to take 7 times the square root of 2. When I do those, is that square root of 14? No. What does this come out to be? They just smush together. Yep, that becomes 7 square root of 2. And then, as always, you see if you can simplify, but can I do anything with square root of 2? No. Okay. All right, go ahead and try this one. On this one, it gave us the hypotenuse this time, still in 45, 45, 90. Does it matter out of 1 and 2 which one I find first? It doesn't matter in this case. What do I know about sides 1 and 2? They're going to end up being the same. Okay, so how do I go back, or how do I go from the hypotenuse back to a leg? Divide by that square root of 2. Yep, what our diagram tells us. So I'm going to take 7 divided by square root of 2. Can I leave that as my answer? No, what do we have to do with that? Yep, we got to multiply top and bottom by whatever that radical is in the bottom. Okay? So this just turns into a multiplication problem. My iPad's froze. There we go. Okay, this just turned into a multiplication problem. What do I get on the top when I multiply those two? 7 square root of 2. Divided by, what do I get when I multiply the bottom together? Square root of 4. Okay? Can I simplify the top? No, top's just going to stay the same, 7 square root of 2. What about the square root of 4? That turns to 2. With division, what do you need to check with at the end? If your whole numbers can cancel or if they can simplify. Can I take 7 divided by 2? No. If you did turn this into 3.5, that's fine. Okay, but you can leave this as 7 square root of 2 over 2.
That would be same both sides.
Correct. Yep, what that just found was both missing side lengths. Okay. So on these, you want your answers to be in radical form. Don't turn them into decimals. Cool? One more thing I want to talk about. If I said the hypotenuse was 10 square root of 2, think of that for a second. Okay? Do you agree we would still divide by square root of 2? Okay, so I'm going to write that down. 10 square root of 2 divided by square root of 2. Could I go through that same process again? I could, but what's a lot easier? These cancel, so I'm just left with 10. So keep that in mind. If things cancel, you can cancel them out. Cool? All right. So with 30, 60, 90 triangles, we kind of have to shift our brain a little bit. What's the most important side? The short leg. In this case, do we have the short leg? 3, right? 3 is our short leg. Doesn't matter out of sides 1 and 2 what I find first. It doesn't matter. I'm just going to pick that side 2. How do I go from short leg to the hypotenuse? Multiply by 2. Yep, so we take 3 times 2, which is 6. That's our hypotenuse. Now, how do I find our long leg?
Go back to 2.
Bingo. Go back to that short leg. Short leg to long leg, we do what? Multiply by square root of 3. Yep, so this turns into 3 times the square root of 3. That gives us 3 square root of 3. Yep. Good. Again, can I go from hypotenuse to the long leg? No. Always have to go from that short leg. On this one, doesn't matter out of my 2 missing sides which one I find first. Which one do I have to find first? Yep. My number 2 here. Gave us the long leg. How do I go from long leg back to the short leg? Divide by square root of 3. Yep. So I'm going to take 3 square root of 2. Divide that by square root of 3. What do I do from here? Yep, I got to simplify. Multiply by that radical on the bottom. On the top and the bottom. So it just turned into a multiplication problem. Yep, what does this turn into? Yep, 3 square root of 6. On the bottom, square root of 9. See if you can simplify. Can I do anything with the top here? 3 square root of 6. No. This stays as 3 square root of 6. What is the square root of 9? 3. What do you always check? If they can cancel or if they can divide. What happens to the 3's? Cancel, so I'm left with square root of 6. In this whole long process, I know what you might forget what you're looking for. Okay, what did we just find there? That gave us my number 2, the short leg. Yep. So now how do I find the hypotenuse from there? Yep, from that short leg, right? From short leg to long leg, short leg to hypotenuse, we multiply by 2. So what's square root of 6 times 2? 2 square root of 6. Good. What does it give us on this one? Hypotenuse. What do we need to find first? Short leg. How do I go from hypotenuse back to short leg? Divide by 2. 18 divided by 2? 9. Right, now I need to find the long leg. Where do I go from and how do I get there? Yep, from the short leg. What do I multiply by? Square root of 3. 9 times square root of 3 is 9 square root of 3. What do you think of when you hear the term ratio? What should you think of? Fraction. Okay, when you did this worksheet, okay, a lot of you were solving these instead of just writing ratios. Okay, whenever you see the word ratio and it asks for the trig ratio, all it wants you to do is write the fraction. Okay, and simplify. So you're not solving for a specific side or a specific angle here. You're just writing the ratio. Cool? All right, whenever you see the word trig, what do you think of? SOHCAHTOA, write that down. Spelling test. Go. See if you get it right. Like I said, if you know how to spell it, you should know how to use it. Double check with me up here. SOHCAHTOA. What I saw a lot of you do on your worksheet, which is awesome, okay, is they split it up like this. Why would you split it up like that? Because a lot of you said that's how it works, right? That's your 3 trig ratios. Okay, so let's start with so. What does the S stand for? Sine. And then sine equals OH. Opposite over hypotenuse. Do you see how if you know how to spell it, you know how to use it? Okay, sine equals opposite over hypotenuse. The second trig ratio, what's C? Cosine of A over H. Adjacent over hypotenuse. And then TOA, T is tangent OA. Opposite over adjacent. Okay. Go ahead and draw yourself a right triangle. You're going to be drawing a lot of those. I'm going to put theta there. What does that theta mean whenever I use that? An angle. Yep, it's the reference angle that you're dealing with. Okay. So there's my reference angle. Which side, no matter where my reference angle is never going to change? Hypotenuse is never going to change. Hypotenuse is always where it's across from the right angle. Okay, so this side's my hypotenuse. Where I have theta right now, which side's opposite? How do I know what opposite is? It's across from that theta. Yep, so this is opposite. And then what does adjacent mean? Right next to. Yep, so the adjacent side is the leg right next to theta. Okay, don't do this, but if I swapped theta to this side, what would change? Opposite and adjacent would switch. Does the hypotenuse move? No. Okay. So in regards to theta, remember I always had you circle that reference angle, just so you know where you're at. What side's the hypotenuse out of 3, 4, and 5? 5 is the hypotenuse. What side's adjacent? 4. What side's opposite? 3. Okay. So sine, we said, was what? What's its ratio? Opposite over hypotenuse. So opposite over hypotenuse, that would give us 3 over 5. Cosine is adjacent over hypotenuse. What would that give us? 4 over 5. Tangent is opposite over adjacent. So that would give us 3 over 4. You would normally reduce, but in this case, do I need to reduce any of those? No. Okay. I'm going to give you more here. What is the hypotenuse on this one? Here's my reference angle. 45. What's the opposite? 27. Adjacent? 36. So for sine, what's our ratio? 27 over 45. Reduce. What can I reduce both those by? 9 to get 3 over 5. Cosine. 36 over 45 reduced by 9 to get 4 over 5. Yep. And then tangent. 27 over 36 reduced both by 9 to get 3 over 4. Now, this is where we are using trig to solve problems, whether it's finding a side or finding an angle. Okay, so I'm going to go through the same process where we had steps earlier. I'm going to go through those again. Okay, so what do I always have you do when starting a problem? Before you label. How do you know what you're labeling? What'd you say? Reference angle. Yep. Step 1 is circle your reference angle. Okay. Now, once we have our reference angle, what did we do after that? Label what? Yep. We're going to label the sides that are given. So what I mean by label is opposite, hypotenuse, and adjacent. Okay. Step 3 is what? Once you have your reference angle and you have, what'd you say? Yes. Pick the trig. Pick the trig based off of the labels that you have from before. Okay. And then 4, once you have all of that picked out, what do? You're going to set up the equation and solve. Yep, write equation and solve. So, circle your reference angle, label the sides based off of the reference angle that's given to you. Number 3, pick the trig that satisfies the sides given. And then 4, you're going to write your equation. Okay. So, let's start with this one. Okay, so what was our step 1? Circle the angle, 44. Are you ever going to go based off of the 90? No. So we have our reference angle, 44. What's step 2? Label the sides that are given. Okay, so let's start with 12. What's 12? That's the hypotenuse. What about x? Adjacent. Do I care about the opposite side? No, there's nothing there for us. What was your step 3? Pick your trig. Yep. So I have adjacent and hypotenuse. Which trig uses adjacent hypotenuse? Cosine. Yep. Step 4. Write the equation and solve. Yep. So cosine, what always goes with cosine? Cosine of the angle, which is 44, equals, now it's its ratio. How does cosine's ratio work? Adjacent over hypotenuse. So this case would be x over 12. Now, remember, this is going to turn into cross multiplication, but I gave you a trick. Do you remember what the trick was? Treat it as over 1, and then you're going to decide, okay, am I going to multiply or am I going to divide? And it all depends on where x is. Okay, so if I think of cross multiply here, what's happening between cosine of 44 and 12? They're multiplying. Yep, so in your calculator, you're going to type cosine of 44, make sure you close your parentheses, and then multiply by 12. What'd you get? Nearest tenth. 8.6. Yep. And that just gave us our missing side. All right, on this one, what's my reference angle? 25. Label the sides. What's 11? Opposite. What's x? Hypotenuse. Do I care about the adjacent side? No. Pick the trig. It is going to be sine because the opposite over hypotenuse. What is always going to go with the trig when writing an equation? The angle. Yep. Sine of 25 equals 11 over x. Does the order of this matter? Yes. It has to go in the order of the ratio. Okay. Again, treat as cross multiplication. What happens this time? X is on the bottom. We're going to dividing. What's the trick that I gave you? They switch places. Yep. Those two switch. So what you have is 11 divided by sine of 25. That's what you type in your calculator. 11 divided by sine of 25. What you got? X 26 even. Yep. And that gave us our missing side. What I want you to understand for this one, steps are the same as finding missing sides using trig. Okay. The only thing that looks a little different is what we're looking for where your x is going to be. Okay, because this time we're looking for the angle instead of the missing side. Okay, but all of those 4 steps are the exact same as what they were from finding missing sides. Again, step 1 is what? What do you do first? Yep, find your reference angle. Next, label the sides that you have. What's 47? Opposite 25. Adjacent. Yep, now you pick the trig. Opposite and adjacent is tangent. What is always going to go with the trig? The angle. What's our angle in this case? X equals,
47.
yep, the ratio opposite over adjacent, 47 over 25. Yep, because now where x is, we are trying to get x by itself. Okay, so how do I get rid of tangent if it's with the x? Inverse. Yep, so if I multiply both sides by the inverse, okay, remember that left side? That's what cancels out the tangent. Okay, inverses are opposites of each other. Okay, so you're left with x equals inverse tangent of 47 over 25. This right here is what you type in your calculator. You do not have to reduce this. Okay, you don't have to just go straight in your calculator. Go ahead, share what you got.
62.
62 even? That gives you that missing angle. Side question. How would I find this other angle if I had that as y? Yes. Could I use trig again? Could, but is there such easier way? Yep. Always remember, angles in a triangle add up to what? 180. Yep. Last one. All right. Reference angle. X. What's the 34? Opposite. 35. Hypotenuse. What trig? Sine. Yep. So sine of x equals 34 over 35. Yep. We got to get x by itself. To get rid of sine, we got to use inverse. So if I type that in my calculator,
76.3.
yes, 76.3.